my name is Jessica Taylor, and I'm the president and principal investigator of the Outer Banks Center for Dolphin Research. And I'd like to thank everyone for coming to the presentation this evening, and I'd like to thank John McCord for inviting me to speak tonight. And I'd also like to thank all of the listeners that are tuning in for the live webcast. Tonight, I'd like to speak to you about the results of a preliminary study examining dolphin skin lesions in the Outer Banks and how mark recapture studies can be used to learn about local dolphin health and in turn get insight into the health of the local environment. And if anybody has questions during the talk, if you could save them till the end and we'll go one by one and talk about people's questions. So I'd like to start out by giving everyone a brief background about the species that we're studying and why we're studying this species. This is the bottlenose dolphin. There are two types of bottlenose dolphins in North Carolina. There's the coastal ecotype and the offshore ecotype. Even though they're considered the same species, they are physically, genetically, and behaviorally different. And the focus of this study is the coastal ecotype. So at birth, they're approximately 3 feet in length. And as adults, they can grow up to about 9 feet in length, about 400 to 600 pounds, although some have measured as large as 1,100 pounds. And these are nearshore and estuarine animals, so they're very adapted to the shallow water. And these are the dolphins that you would typically find in the sounds and bays and estuaries and right along the ocean front. And although at one point they were believed to be generalists in terms of feeding, studies in the North Carolina Sounds have found that they target small sound-producing fish, such as croaker and spot and drum. The offshore ecotype, they're a little bit bigger than these dolphins and a lot darker in color, and they would be found further offshore in deeper waters. So they're better adapted to the deep water. They feed primarily on fish and squid that they find offshore. So that's just the distinction between the two types of bottlenose dolphins in North Carolina. So for the remainder of the talk, when I refer to dolphins or bottlenose dolphins, I'm referring to the coastal ecotype. And all bottlenose dolphins are protected under the Federal Marine Mammal Protection Act of 1972. And that act says that it's illegal to hunt or harass any marine mammals in United States waters. And harassment includes anything that would change their behavior. The responsibility for enforcing this act for cetaceans, which are dolphins, whales, and porpoises, falls under the responsibility of the National Marine Fisheries Service. And the National Marine Fisheries Service is assisted in monitoring marine mammal populations by research organizations and universities. The Marine Mammal Protection Act also says that all marine mammal populations must be maintained at their optimum sustainable population, which basically means the highest levels possible, and that they must be maintained as functioning elements of their ecosystem. So if there are any populations that drop below their OSP or can no longer be functioning elements of their ecosystem, then a conservation plan needs to be developed. And in 1988, the Atlantic bottlenose dolphin population did drop below its OSP. And this was due to a large die-off that occurred from 1987 through 1988. And over the course of about 9 months, there were about 742 dolphins that stranded between New Jersey and Florida. And the stranding started in Virginia and progressed north to New Jersey and then made their way back down south to Florida. So the Outer Banks probably would have experienced these strandings in August of 1987. The cause of the die-off was later determined to be a disease called morbillivirus, which is similar to canine distemper, and this type of morbillivirus is specific to dolphins. And this morbillivirus likely spread through the population during the seasonal migrations when the most mixing occurred. And I say there were at least 742 dolphins because there were probably more, and a lot of the strandings probably went unnoticed or were unreported because stranding centers were pretty sparse at the time. There weren't many of them. And there was also minimum data available on the population size. For Atlantic bottlenose dolphins, there hadn't been a whole lot of studies that had been done. But based upon the pattern of the strandings and what was known about the population size at the time, it was estimated that this die-off represented more than 50% of the population, which was deemed to be unsustainable. And so a conservation plan that called for increased and more intensive monitoring efforts was initiated. And morbillivirus is a disease that dolphins will build up an immunity to, but it can resurface in wild populations. And in 2013, there was an unusual mortality event declared for bottlenose dolphins from New Jersey to Florida. And based upon the strandings that were obtained from the animals, they found that most of those animals tested positive for morbillivirus. So that was believed to be the cause of the most recent stranding event as well. So this conservation plan that was developed in the 80s involved determining the specific bottlenose dolphin populations or stocks that occurred along the Atlantic coast. And a stock of marine mammals is a group of marine mammals that are the same species that live in a common spatial area and interbreed when mature. So determining the different dolphin stocks involved using field observations, tagging studies, genetic studies, and an examination of the stranding records. And based upon the pattern of the 1987 and 88 strandings, it was believed that only one stock or population of dolphins existed in the Atlantic Ocean, and this was known as the coastal migratory stock hypothesis. So it was believed that this stock made one full seasonal migration. And in the spring, all of the dolphins would migrate north, and in the fall, the dolphins would migrate south. But with further research, we found that the movements of dolphins in the Atlantic Ocean are much more complicated. So further studies have shown the multiple stock hypothesis to be more widely accepted. And with the multiple stock hypothesis, we know that dolphins may exhibit year-round residency in areas, they may exhibit seasonal residency, or they can exhibit more long-range transient movement patterns. So this is the model that more accurately represents how bottlenose dolphins are moving around the Atlantic Ocean. Probably one of the most valuable tools that has been used to learn about the movement patterns of bottlenose dolphins is known as photo identification. And photo identification is a non-invasive mark recapture technique in which the distinguishing markings on the dorsal fins of dolphins are photographed. A sighting data sheet, including the GPS location of where the group is, the group size estimates, and environmental variables such as water temperature and salinity, is recorded for each dolphin group. And the dorsal fin images and sighting data are linked in a catalog and maintained in a catalog over time. So for anyone that's familiar with mark recapture techniques, there's usually some type of tagging of the animals involved. And what makes this technique really great is that it's very non-invasive, so the animals don't need to be tagged. All that's needed is the photograph of the natural markings on the fins. And photo identification has been useful for identifying individual dolphins and tracking their movement patterns across areas, for studying their behavior, and for estimating population sizes and stock sizes. It's the technique that the Outer Banks Center for Dolphin Research uses for studying the dolphins in the Outer Banks. And approximately 52% of the dolphins seen in the Outer Banks Sounds are readily identifiable by natural markings. So since 2008, the Outer Banks Center for Dolphin Research has used photo identification to study the dolphins and the sound surrounding the Outer Banks. Since dolphins are considered a protected species, we work under a scientific research permit issued by the National Marine Fisheries Service. Our study area is Roanoke Sound, which is the body of water that separates Roanoke Island from Nag's Head. And in Roanoke Sound, our study area ranges from the Lost Colony in the north to Oregon Inlet in the south. And our study season spans from April through November, which is when dolphins are most likely to be seen in the Sound. So we conduct monthly or bi-monthly transect surveys in which we follow a standardized, predetermined transect route that's the same for every survey. So these graphs illustrate the seasonal average water temperatures and seasonal average salinities for Roanoke Sound based upon our long-term data set. So as you can see, the seasonal average water temperature pretty much mirrors what happens with the air temperature in the Outer Banks. So the average water temperature is lowest in the spring and peaks in the summer and then tapers off into the fall. And this is probably a function of the shallow depths in the Sound. So the average depth of Roanoke Sound is about 3 to 4 feet, with the exception of the channel, which is about 6 to 12 feet. So with the shallow water, it doesn't take very much time for the water temperatures to change. So the water temperature is a pretty good reflection of what happens with the air temperature. With the seasonal average salinities, they are pretty stable year-round, and that is probably more of a function of the proximity to Oregon Inlet than it is the time of year. We found the salinity at Oregon Inlet inside the Sound to range from about 25 to 32 parts per thousand, and at the most northern point of our study area near the Lost Colony to be about 7 to 8 parts per thousand. So the salinity pretty much depends upon where you are in the Sound. It also might be a function of the wind speed and direction as well. But the Sound is a pretty favorable habitat for bottlenose dolphins during the warmer months. There's not many predators in the Sound. The most likely bottlenose dolphin predators would be sharks. And due to the low salinity and the shallow depths, sharks are pretty rare in Roanoke Sound. There's also an abundant food source for dolphins in Roanoke Sound, and we typically see the dolphins foraging over the seagrasses and the sand flats, as well as in the channel, down closer to the inlet. And so with these two factors, it combines to make the Sound a good nursery area for the dolphins. The lack of predators is important for the moms and calves, and sharks would be more likely to target mom and calf pairs. And the abundant food is good for the nursing moms because when they're nursing their calves, they have higher energy demands and they need to eat more. And we do see a lot of mom and calf pairs in the Sound, and we see the most newborns in the Sound during the months of May and June, so right about now. And we have seen several newborns already this season. So dolphins are important components of the coastal marine environment, and the close relationship that dolphins have with their habitat makes them good indicators of environmental health. So bottlenose dolphins are considered important indicator species of the coastal environment, and they serve as a measure of ecosystem health. Due to their long lifespans and their presence at the top of the food chain, the effects of natural and anthropogenic stressors on the environment are visible through the local dolphin population. So in particular, dolphins will concentrate contaminants through their bodies throughout their lives, and these contaminants may be man-made, such as persistent organic pollutants, which are chemicals that persist in the environment over long periods of time, or they can be caused by natural microorganisms in the water, such as red tides. And these contaminants will accumulate in the dolphins through the process of bioaccumulation. The man-made chemical loads in the environment, usually resulting from agricultural runoff or factories or burning of plastics, chemicals will be integrated into the marine food chain at the very bottom, and they'll move up the food chain. So as predators will consume the next trophic level down, the concentrations of these chemicals will increase or biomagnify. So the top predators are the ones that have the greatest concentrations of these contaminants because they're eating more food. And dolphins will store these contaminants in their blubber or in their fat, and they typically don't pass through their body. So as a dolphin ages, its contaminant load typically increases. And this contaminant load is thought to be one of the reasons why females may experience a longer lifespan than the males do. The females are expected to live about 50 to 55 years, and the males about 40 to 45 years. When the females are nursing their calves, they're able to offload some of these chemicals in the milk that goes to the calf. So it's thought by being able to get some of those chemicals out of their bodies, it allows them to live a little bit longer. But unfortunately for the calves, they get a dose of those chemicals, especially the firstborn calf gets the largest dose. And the firstborn calf of a bottlenose dolphin does have the lowest chance of survival. When the seasons change, the dolphins, as the weather gets warmer, they'll also metabolize their blubber. And so that may push some of these chemicals into their bloodstream, affecting the dolphins. Probably the most significant contaminants that are known to be found in bottlenose dolphins are known as PCBs, or polychlorinated biphenyls. And those chemicals are known to cause cancers and reproductive failure in marine mammals as well as in humans. And so as in the process of bioaccumulation, these chemicals may be also consumed by people through eating seafood. So by monitoring the health of the local dolphin population, it gives us a lot of insight into the contaminant loads in the environment. There's also an empirical link between the movements of dolphins and the movements of fish in the marine environment. Dolphin movements are largely dependent upon the movements of their prey. So as the fish move around, the dolphins will move around, most likely following their food. So the presence of dolphins in an area can also give insight into the fish populations. I also mentioned that dolphins can be indicators of natural stressors to the environment. And an example of one of these natural stressors is known as red tides. Red tides are a type of harmful algal bloom, or HAB, and are caused by a toxic dinoflagellate algae known as Carina brevis. And these Carina brevis produce brevetoxin, which is a potent neurotoxin. It's known to cause fish kills and mortality in marine mammals. The brevetoxin can also accumulate in shellfish, which, if consumed by people, can cause neurotoxic shellfish poisoning. And recently, Dr. Spencer Fire and his colleagues in Florida documented a link between two harmful algal bloom events and a mass mortality event of dolphins and manatees on the north central Florida coast. From September 2007 to January 2008, there were 14 dolphins and 33 manatees that stranded along the north central Florida coast. And during that time, they detected two harmful algal bloom events of red tides in the same area. Once they analyzed the stranded dolphins and manatees, they found the majority of them to test positive for brevetoxin. And they also, during the necropsies, examined the stomach contents, and they found the finfish in the stomachs of the dolphins and the seagrass in the stomachs of the manatees to also test positive for brevetoxin, suggesting that this toxin was transferred through food source. So in that way, these strandings served as a warning sign of a natural stressor to the environment that could also affect people. So monitoring the health of the local dolphin population can give insight into the health status of the local environment, but the question becomes, what is the most cost-efficient and least invasive way to monitor the health of wild bottlenose dolphins? And one way is to use the process of photo identification to examine skin lesions on dolphins. Skin lesions have been observed on many different types of marine mammals. They vary in size, color, shape, and form. Photo identification is useful for identifying and monitoring the skin lesions, but it's limited in linking the lesions to their causative factors. There have been some studies that have been successful in linking the lesions to their causes by examining the lesions on stranded animals. So lesions may be reactions to environmental variables such as low water temperature or low salinity. They could be indications of bacterial, viral, or fungal diseases within the population, or they could be reactions to environmental contaminants. And when dolphins are exposed to low water temperature, low salinity, or environmental contaminants, their immune systems become suppressed, which may make them more vulnerable to disease. So in 2012, I conducted a preliminary study using photo identification to examine skin lesions on dolphins observed in Roanoke Sound. And the methods in this preliminary study were based upon the work of Dr. Leslie Hart in Charleston, South Carolina. Dr. Hart used photo identification to examine the skin lesions on wild bottlenose dolphins in 3 different study sites. So she looked at Florida, Georgia, and South Carolina, and she also examined the histopathology of lesions from stranded animals. And in some cases, she was able to make a link between some of the lesions and their potential causes. She also found the prevalence of lesions and the lesion type to vary in the different areas in which she worked. So Dr. Hart identified 13 different types of lesions, which are pictured over the next couple of slides. The lesions that have been identified in the Outer Banks are marked with a star. So we've seen black lesions, pale lesions, lunar lesions, dark fringe lesions, white fringe lesions, tattoo lesions, white velvety lesions, vesicular lesions, and spotted lesions. And these are all images taken from Dr. Hart's dissertation research. So by linking the processes of photo identification and examination of the lesions from stranded animals, she was able to make potential links between some of the lesions and their causes. She found that there was a higher prevalence of lesions associated with low water temperature, especially dark fringe, tattoo, and vesicular lesions. Pale lesions were suggested to be caused by a variety of causes, such as healing from trauma or viral infection. These could have been the site of parasite attachment, or they could be due to inflammation. Through a PCR analysis, she found a link between white fringe lesions and herpes virus. She also found a link between laccoziosis-like lesions and lobomycosis, which is a fungal infection that's also known to be a zoonotic. So identifying the visual presence of lesions within the population is a useful tool for screening the population for potential disease. In 2012, we conducted monthly photo identification surveys in Roanoke Sound from April through October. We defined 3 seasons based upon the water temperature in the Sound. Spring was defined as April and May, summer was June through August, and fall was September and October. We used all the sighting data and dorsal fin images were maintained in a Microsoft Access database known as FinBase, and it stores all of our sighting data and links it to the dorsal fin images. Fin base is also used for grading the quality of the dorsal fin photos and matching them to dolphins in our catalog. And every match was verified by a second researcher. So there are 2 sets of eyes looking at every match. I selected the distinctive good quality fins for this analysis and examined each dolphin photo for the presence of skin lesions. If I identified lesions, I identified the type of lesion, the size, the shape, and the form. And then I calculated the seasonal and overall minimum lesion prevalences. And I used the term minimum lesion prevalence as I wasn't able to calculate for the entire population, because we probably didn't see the entire population in 2012. So what I calculated was for a sample of the population. So minimum lesion prevalence is the minimum prevalence that might be out there. And I also determined the most common lesions that were observed. I also conducted a residency analysis on the sample population to see if there was a relationship between the lesion prevalences and the type of residency pattern a dolphin has. And I found 2 types of residency patterns in Roanoke Sound. We have seasonal residents and we have transients. Seasonal residents were defined as dolphins that were seen in the study area in 1 or more seasons across years, and transients were defined as seen in the study area during only 1 season. And for the analysis of every dolphin's residency pattern, I used our entire data set in fin base since 2008 to define their residency pattern. And then I calculated the overall and seasonal lesion prevalences for each residency type and then compared the results. So in all, I screened 240 digital images of 83 distinctive dolphins for the presence of skin lesions. I calculated the minimum lesion prevalence by taking the number of individuals I saw with lesions and dividing this by the number of individuals that were seen overall. And I found the overall prevalence to be 0.45 or 45% of the sample population with lesions. And of the dolphins that had lesions, about 1/3 of them had more than 1 lesion type. To calculate the seasonal lesion prevalences, I used the same equation but looked at the numbers of dolphins by season. And I found that there were significantly more lesions seen in the spring than any other season. And this could be due to the low water temperatures that we have in the spring, so they could serve as a stressor to the dolphins, making lesions more prevalent. I calculated the prevalence for each lesion type, and in order to be considered a major lesion type, it had to be greater than 0.15. And I found 3 major lesion types in the Outer Banks. There were black lesions, dark fringed lesions, and pale lesions, with the pale lesions being the most common overall, but I didn't find a significant difference between the prevalences. So these are some of the major lesion types on the Outer Banks dolphins. So these are the dark fringed lesions. These are, over here, are the black lesions and the pale lesions. So if you remember, the dark fringed lesions were associated with low water temperatures. The pale lesions could be caused by a variety of factors. Based upon the residency analysis, 35% of the dolphins seen in 2012 were classified as seasonal residents, and 52% were classified as transients. The percentages of transients were greatest in the spring and in the fall, and the percentage of seasonal residents was greatest during the summer. The bars over here show the percentage of each group that had lesions, but there were no significant differences between the residents and the transients. So there is likely an environmental influence on lesions observed on dolphins in Roanoke Sound, as the greatest prevalences were seen in the spring and the lowest water temperature is commonly seen in the spring. And low water temperature is known to have an influence on lesions. It's possible that because of the low water temperature, we're seeing a greater prevalence of the skin lesions. Roanoke Sound, also the overall prevalence was similar in type and similar in this type and occurrence to other East Coast study sites. So I mentioned a similar analysis has been done for Florida, Georgia, and South Carolina, and those prevalences ranged from 0.38 to 0.58, with the largest prevalence being found in Georgia. So the Outer Banks seems to fall about right in the middle of what's been seen in other places. And this was a preliminary study, so part of the purpose of this study was to test out these methods to see if we could continue this study. And these methods do seem suitable for this area for further examination of the skin lesions. So this preliminary study has opened up a lot of doors for future directions with this research. And this is going to be a multi-year study so that we can look at the prevalence of lesions across years. I just finished examining the 2013 photos to compare to 2012. So if we can examine these lesions across years, we can look and see if there's variability over time. And so maybe in certain years there might be different environmental factors or different diseases surfacing within the population. Including more years in the study will also make it possible to look at the lesion type by season to see if certain lesions are more common in particular seasons, and to look at the prevalences of lesion types across years. I'm also interested in looking more at the residency patterns and their relationship to skin lesion prevalence, and also incorporating our environmental data, such as our water temperature and salinity data, because it is hard to use photo identification to look at causative factors, but by incorporating the water temperature and salinity, it may give some more indication of possible environmental stressors to the dolphins. So I'd like to finish up by acknowledging everybody that's contributed to this research. The Outer Banks Center for Dolphin Research is an all volunteer-based organization, so our volunteers are pretty integral to all of our field data research, especially Jay Taylor and Dennis Silveri. I'd also like to acknowledge our interns that come every summer that help with processing our photo ID data in FinBase. The Nags Head Dolphin Watch has continuously supported the research over the years by serving as a platform for opportunistic photo identification research, and we can gain a much greater insight by being out on the dolphin tours and being able to collect this research. We can learn a lot more about the dolphins than just through our dedicated surveys. Jeff Adams at NOAA has assisted over the years in maintaining the FinBase database and provided a database for recording the skin lesions. Dr. Leslie Hart assisted with examining the skin lesions through photographs and with the statistical analysis. Todd Speakman of NOAA assisted with designing the transect lines for the dedicated surveys, and Eric Zollman gave advice on defining the residency patterns. And Kim Urian of the Duke Marine Lab is our scientific advisor, and she's given a lot of input and insight into all of our photo identification research. And so I can take any questions at this time.